Hello and welcome to another edition of Momentum. I'm your host, John Mercado. My first guest is Dr. Anna Linhoss, an assistant professor in the Department of Agricultural and Biological Engineering. Anna, thanks for being with us today.
Thanks for having me. I appreciate it.
So let's talk about some of your research. First up, marsh restoration and methods. Why don't you tell us about that research of yours?
Yeah, so Louisiana, the coast of Louisiana is sinking faster pretty much anywhere than any other marshes in the whole United States. So we're losing those marshes because of subsidence, the land is sinking, and also because of sea level rise. So people are trying every sort of method they can think of to preserve those marshes because they're habitat for animals, birds. They provide important ecosystem services like to prevent flooding and that sort of thing. So one of the techniques that people have been using for about 20, 30 years now is a thing called marsh terraces. And it's where they go out with big backhoes and that sort of thing, heavy equipment, and build up segmented dikes in the middle of these ponds in the marshes. And that's supposed to reduce wave action, which should prevent erosion and help encourage marsh growth and marsh building. So they've been doing this for about, like I said, 25 years. And there's about 1,000 linear kilometers of these terraces that have been put in. And nobody's done any science to understand how well they work, how well you should design them, nothing. People just build them kind of from trial and error. So we have a project funded by the National Academies of Science to look at these terraces and try to understand what's the best way to design them to get the optimal restoration for the build, for the money.
Okay. And will this have applicability in other places, or is it, obviously it's mainly just in Louisiana, but is it something that could be extrapolated to other parts of the country?
Absolutely, absolutely. That's one thing that we're hoping to do, is to take this over. There's a couple of them in Texas, but not many, but to take the idea and see if we can apply it throughout the Gulf of Mexico.
Okay.
To restore other wetlands as well.
Very good. There's some other research of yours involves land conservation. Why don't you tell us about that?
Yeah, so land conservation is a big deal in the Gulf of Mexico because of the BP oil spill. Back in 2010, we got billions of dollars funded for science and research and preservation in the Gulf of Mexico. And a lot of that money is going towards land conservation. So buying up parcels of land that will be set aside for conservation kind of forever. And so people are having to make decisions kind of at a regional level of which parcels to buy and preserve. So if you have 1,000 acres of mangroves in Florida and you've got maybe like 100 acres of scrub shrub in Texas, which one do you preserve? Which one do you buy? How do you make that sort of decision? And so what we're doing is we're coming up with a model, multi-criteria decision analysis model that takes into account all sorts of different things, like how much does it cost, how many threatened and endangered species is on there, how many acres, water quality, land use, all sorts of things. Combine that all into one and to be able to make decisions. And the great thing about it is we're making a web app, a spatial map. So you can draw in your different parcels that you're interested in conserving, wow, and then you're able to compare them and see which one wins and why does it win.
Wow. And then I also read that you've done some work on oyster research in the Mississippi Sound. How about that?
Yeah. This work's funded by the National Fish and Wildlife Federation. So the oyster industry in Mississippi and the Mississippi Sound's always been pretty important. We get about $60 million a year from it right now. And 10 years ago, it was much larger. It was a much more important industry. And after the double whammy of Katrina and the BP oil spill, our oyster industry, the production, is down about 90% of what it was pre-2010. And so in 2015, the governor declared the Year of the Oyster. And so there's been a lot of effort into restoring those industries because it's an important economic industry for our coast. So what we're doing is people want to put in oyster restoration reefs. So build an artificial reef in different places to encourage oyster development. And so where do you put those reefs in? That's the question we're trying to answer. So we're using hydrodynamic, which is like a water flow model, and a water quality model for the western Mississippi Sound to understand where should we put these oyster restoration reefs, and will the oysters survive in like a high flow hurricane type event, or will they survive in a really dry, hot summer? So to make sure that the oyster reefs are there and resilient, that they'll be able to make it through these different storms and seasons and that sort of thing.
We're doing some really fascinating work, and I appreciate you being here to share that with us today.
Thank you.
Thanks.
Great to be here.
Thank you. We'll be right back after a break.
What drives you? What pushes you forward? Is it an appetite to be the best, or a calling to make a difference? For those of us here at Mississippi State University, it's both. We're designing a future where cutting-edge hybrid technology isn't imported from overseas, but exported from our own backyard. We're working toward a day when solutions to energy independence move at 0 to 60 in 5.5 seconds and are as simple as charging a phone. A day when fuel economy and environmentally friendly are viewed as less of a compromise and look more like this. For us, turning heads in the auto industry is great, but living up to the hype is even better. That's because it's about more than simply envisioning the future. It's about getting there. And here at Mississippi State, we know just the ride to take. Imagine research that opens new avenues of evidence for crime scenes. We are at Mississippi State University, where we ring true. When you're the best, everyone wants to see what you'll do next. At Mississippi State University, our team of world-class rocket engineers is venturing beyond boundaries, building rockets like none before. We're launching a new era of space exploration. We've developed cutting-edge technology that's helping us build a rocket that can travel at 4 times the speed of sound. Fast? Yes. But more importantly, revolutionary. For you and for a space program that produces many of the conveniences we enjoy today. We're shaping your life in ways you never dreamed. What's next? Watch us and see. Imagine a helmet so protective that it transforms the safety of the game. We are at Mississippi State University, where we ring true.
Welcome back. My next guest is Dr. Reuben Burch, an assistant professor in the Department of Industrial and Systems Engineering. Reuben, thanks for being with us today.
Yeah, thanks for having me. Appreciate it.
So you recently won 2 NSF grants for wearable technology design. Why don't you start out by telling us about that?
Sure. Yeah, the first one was the NSF PFI, stands for Partnership for Innovation. And the neat part is you're supposed to go out and find an industry partner that's going to help you advance some sort of technology that someone would actually want to buy. That's one of the trends that NSF is starting to look at. So we're looking at building a foot ankle wearable that captures ankle movement and ground reaction forces. We do a lot of work with the athletic department. And the second grant was the NSF I-Corps, which had us go out and interview close to 150 strength and conditioning coaches. So the combination of the interviews plus the grant we won, we know that athletic trainers want data collected from the ground up. We were even able to work with the E-Center and start a new Mura company called UMO, which is Latin for from the ground up. So all of it's worked together really well. We're using new liquid metal, liquid wire technology sensors that fit into a compression wearable sock that, in theory, should be as accurate or almost as accurate as a motion capture system in force plates in a lab. But real work doesn't happen in the lab. You know, real things happen in the real world, like on the field, on the court, in the facility, things like that. So that's the goal of the grant, is to try to build this prototype that people will then purchase.
And so a really interesting part of your background that actually ties right into this is the fact that you played football at MSU while you were getting an engineering degree, which is just insane sounding. What can you tell us about that experience?
Yeah, I wouldn't recommend that much, unless, of course, you're a top recruit looking to come here, at which point it's no problem. Please come on. Right. But it was computer engineering degree is what I got. Come from an engineering family, so there really wasn't much of choice about, not going to be an engineer. I played fullback, did a lot of special teams. Mostly special teams. I played behind some people that went pro and had a nice, long, illustrious pro career, so I had a very nice seat for most of the games, so that was great. But it was tough. I had to learn pretty quickly the whole discipline and, time schedule maintenance, doing the things you need to get done, focusing on priority. And the good news is that after college, there hasn't really been anything that's been harder than that. So I feel I was able to kind of peak at, early 20s in terms of things that were hard. Right. And it was, able to move on and knock out some other things in life that didn't feel quite so bad.
Wow. And then you're involved with a multidisciplinary group called Athlete Engineering. Why don't you tell us a little bit about that?
Right. The Bagley College is really good about supporting interdisciplinary research, and they allow us to create and propose working groups. And one that we proposed was called Athlete Engineering. So I'd say we have about 30 members. Half of them are faculty in disciplines like obviously industrial, electrical and computer engineering, mechanical, ag and bio, kinesiology, psychology, a lot of different faculty from there. But then the other half are all of our strength and conditioning coaches and athletic trainers from the different sports teams. And so we're able to focus on going after these types of grants, like the ones we won with the NSF, and also discuss the state of wearable technology, partner with research. Is it economical to purchase these wearable solutions? If they are, we're going to be able to put them in the lab and find out and give them a straight answer on which solution maybe they should look at purchasing. They now have mountains of data associated with athletics. A strength and conditioning coach nowadays almost is a data analyst, but they still have their daytime job, which is, training the student athlete. So, right. How can we help do data analysis, not just on the student athlete, but, some type of comparison between the tech, because it's a technology arms race nowadays in college sports. So, we can help them with that.
Real quickly, what is the current state? Some of the stuff you're talking about, does it already exist in other places in some form, or is it really just sort of bleeding edge technology at this point?
It's a little bit of both. If you've been an early adopter where you've been doing this for years, you've kind of been able to go ahead and hone in on the type of data you need to make those decisions. Right. But so many teams aren't there yet. They're not ready for the technology, and so just they're trying to acclimate it to it. Thankfully, Mississippi State's been doing it for a while, so we got some pros on our side.
Okay. Well, it's great talking with you. This is tremendously interesting stuff. I appreciate you spending time with us today.
Yeah, thanks for having me. Appreciate it.
That's our show for today. Remember that you can follow us at MSU Engineering on Facebook, Twitter, and Instagram. Thank you for watching.